We're going to talk today in a very simple, basic way about adding automation or adding a bar feeder to an existing lathe. We're going to break it down really in three topics. Things we're going to cover. We're going to talk about the most important requirements for adding a bar feeder to an existing lathe. We're also going to talk about some notables when buying a bar feeder in a used market to put on an existing lathe. And then finally, we'll finish up with a handful of tips on going to lights out automation. So let's talk about the three must-haves. There's three very certain things that we must have in order to add a bar feeder to an existing lathe. And the first one is actually the interface, the electrical connection that's supplied by the OEM or the lathe. The important thing to find out there is on the rear of the sheet metal of the lathe, the back, most likely you'll see some sort of connections, some plugs, a cable, a cover. That's usually the first tip that we actually have this interface that we need installed in the machine. So you can see that they're round connectors, square connectors, any of those. So that's the most important thing. If you don't see that device or have an interface connected to or on your machine tool, the best type of things to do is to go to the OEM, the manufacturer of the lathe, utilize the serial number, and so they can see during the build if the build of the machine tool got the interface put into it. And the third thing that we want to talk about on that is the actual keep relays in the control that actually turn on the interface. So even though that the wiring is there and that the connections are part of the machine tool, we got to be able to turn it on. You can kind of consider this last thing much like the key to the ignition on the car. So you might have the ignition with the interface, but you don't have the key to turn it on. So in order to start the car or start the interface, it needs to be activated by the lathe OEM or distributor of that machine tool to get the actual interface working. So that's the first most important tip. Number two would be that we would use a dead length collet chuck, something unique in regards to workforce. In the bar loading world, a 3-jaw chuck is sufficient, but it poses a lot of problems. Sometimes the back of a jaw is really flat and square, so if we're trying to automatically reload, we might be hitting a blockage of the jaw. So when we go with a actual dead length collet, the inside of that collet's very tapered, and that allows us to get the bar up on center for reload. Uniquely enough, the dead length also positions the bar so that it doesn't move the material. So any other type of chuck system, push to pull or a pull to close, they have the opportunity of moving or repositioning the material, which could create a long or a short part. So super important. Bar feed interface, dead length chuck, and the third must-have obviously is a parts catcher. We got to have a way to get the parts out of the machine. So a simplistic parts catcher will get us our component out, allow to do some continuous production. Now for some of you, you might have a main spindle machine, a sub spindle machine. Depending on the part process, we need to make sure that we have the parts catcher installed maybe on one or both of those. And so parts catchers typically are good for overall length of parts somewhere around 6 inches. So anything longer than that, we have to think about some sort of mechanical unloader or a different variant. So those are our three must-haves in order to add a bar feeder. We got to have the electrical interface supplied by the lathe OEM. We got to have a dead length collet chuck for superior work holding, and we need to have a parts catcher. We'll give you three more tips. We will call them like to haves. So they're certainly also important. We obviously would consider a chip conveyor at this point because we're going to have more continuous production. And in that production, we're going to need to alleviate the chips so that we don't have any issues with the linear ways of the machine tool or any function. So certainly a chip conveyor is a like to have. The second one would be some sort of spindle load monitoring. So now that we might be doing other functions while running that machine, we've got some unintended production. The machine may be able to run unmanned for a few hours. we would certainly want to be able to spindle load or monitor at least our tooling to make sure that we don't get we can predict a failure of an insert, a cutoff, maybe a drill. So certainly considering some load monitoring software works. And finally is going to be the mist collection. So maybe before you were hand chucking the job, you're opening and closing a door and a lot of that mist is getting in there, but we put this thing now into a full-blown production mode where we're making a short cycle time rapidly. It's quickly overlooked is the mist collection. So we're going to do a quick demonstration right over here with Dan Borders. We are also showing 2 of our mist collectors today. The mist collector that we're demonstrating here in the laser box is for a water-soluble solution, so you can imagine we would have the mist blowing. Go ahead, Dan, take it over.
Yeah, Dan Borders, Edge Technologies, Vortex product manager. We do have our 2 units here, the AF series up top, which is actually working with this box here. That's going to be for your water-soluble coolants. We do have 4 models there, the AF10, 20, 30, and 40 for different size machine tools. And then the one in the lower half there is our OS550. That's for all your cutting oils. We pretty much standardize that unit more for a Swiss size machine or a small grinder, more applications where you're using hard cutting oil. And you can kind of just see as we work through it, the Vortex AF10 will actually get this box clear enough to where you won't see that laser light anymore. So it's a really good option for water soluble and hard cutting oils.
Thanks, Dan. Let's talk about the notables. So we're going to transfer into potentially buying or looking at buying a bar feeder in the aftermarket from a used machinery dealer, from your neighbor, from somebody down the street. Maybe somebody has a bar feeder and they want to sell it and you're considering adding it to your machine tool. So there's 5 or 6 things we certainly want to consider. And the first thing is the actual voltage that the bar feeder operates at. There are certainly different voltages on machine tools. A European machine sometimes is built with 400 or 460 volt. A Korean, Taiwanese, Japanese machine tool builder typically builds things 200, 208 voltage. The most important thing buying a used bar feeder, do not plug it into the machine tool. If the plug looks like it fits, don't tempt yourself. The wiring is most likely different from the manufacturers that could create an expensive failure due to sending a leg of 3-phase into the machine and wiping out all the 24-volt switches or something. So even though the connectors look like they fit, do not plug that into the machine because there certainly could be some differences in the wiring. So first thing is most important, voltage of the machine. That definitely has an effect on pumps and motors, so we would want to make sure that those are compatible. The second thing is spindle center line. And that might require different accessories. All the machines you guys are leaning on are adjusted by the legs to different spindles. However, manufacturers make spindle center lines at different heights. For instance, a machine that might have a 3rd turret in it or a lower turret forces the spindle up much higher, which forces the bar feeder center line higher. So we have to make sure that the accessories, the legs, the stands, and all the components have the ability to get high enough. Or if it was on a high machine, can it get low enough to go to a different machine? So voltage and center height. We also need to talk about the actual pusher length. So the bar feeder utilizes a pusher to hold the end of the material, retract the remnant, and keep things in production. Uniquely enough, that pusher is configured in 3 or 4 different lengths. And we need to make sure that that pusher accepts the length of your spindle, chuck, and so on and so forth. So that kind of dictates the position of where it gets installed from the back of the machine tool. Sometimes you'll see the bar feeder may be installed 8 inches, 10 inches, 16 inches apart. That's all part of this pusher length process. Certainly we want to make sure that we're looking at a Swiss or a fixed headstock application. Obviously the Swiss machines require many more components, the telescopic noses, the synchronization devices, things that travel with Z, or more of a conventional fixed headstock machine doesn't require any traveling components. It's sitting right up to the back of the machine, so we have to consider those going from a Swiss to a fixed or vice versa. Spare parts and availability, well, you certainly want to make sure that the OEM of that bar feeder has those parts. So there's a lot of intriguing 15, 20-year-old bar feeders out there for sale. However, maybe those electronic components, PLCs, HMI, CPUs are no longer supported. So certainly you would want to make sure that you have availability and spare parts of that machine. And interchangeability in shared components is nice. So if you already have a bar feeder or a similar bar feeder, there's a lot to be said about continuity of operation of the machine, the control, the collets, the bushings, the channel sets and pushers. So something also to consider when looking at this. So the final thing that I'd like to talk about is going to a level of lights out manufacturing. So I think we're all starting to think that way. COVID taught us a lot of things about running unmanned, less people. We're probably all re-gearing our business philosophies at this point. So let's talk about 5 things that can make our business look like this. So that's certainly 20 or 30 machines running unattended by themselves for 8 hours at night. Obviously, one of the most important things is to have enough space or storage for that amount of finished parts. So adding a parts accumulator or a parts collector is really important. The nice thing about this type of device, you can see the little illustration starts off at the end of the day on Tuesday. We run the bar feeder Tuesday night and into Wednesday morning and collect parts. Uniquely enough, you can kind of create a gauging of this part where if you do find a characteristic that might be out of tolerance, it's easy to figure out which ones you would have to check and figure out which parts are good. So that's a really nice system to add. Secondly, you might need extended materials storage on the bar feeder side. Maybe the bar feeder is only capable of running 2 or 3 hours without needing it. So there are several ways to extend the material storage on the bar feeder. The picture shown here is what we call a bundle loader. Really doesn't care about the amount of bars, it cares about the weight. So this particular device handles 5,000 pounds of raw material. So you would, with an overhead crane or a fork truck, load this down into the machine, the bundle loader, and continuous production. The system's really good for high volume dedicated work. So maybe someone making a 15, 20, 30-inch shaft that's doing a bar change every 2, 3, 5 minutes. That's a perfect solution for that. Sometimes just an extended rack, just an extended plane on the bar feeder is also good. And that can add 6 or 8 hours to storage. We want to make sure that that's got ground support so that we're not leveraging the bar feeder by adding too much weight. And finally, we also make a device called a bar lift. And so maybe it's not so much the fact that you need additional storage, but you don't want your operators lifting heavy bars. So maybe a 2-inch diameter 12-foot bar exceeds your shop regulation. It weighs too much for an operator. So we have an elevator system that will automatically deliver the machine or the material into the bar feeder. So number 3 kind of goes back to what we talked about, in-process gauging. We certainly would want to have the ability, if we're going to run unattended, to make sure that we make good parts. And to do that, we might need to use a third-party source of internal gauging, a company like Karen Engineering or someone like that that actually is collecting data, checking parts for you in the process while you're making it, and certainly detecting any load tools for a broken tool. So engage processing may be necessary. Redundant tooling on your turrets is a great idea. So maybe we've determined that a cutoff tool is only worth 300 parts. The shift is certainly capable of making 600 parts. We would want to make sure that we have a redundant tooling in there and the capability automatically to go from tool 1 to tool 8 in process. So that, and finally the last thing would be some sort of remote monitoring. And this is a big tag catch that everyone hears now. It can start simply with nothing more than a camera in your shop on the patrol light of the machine. It could be something provided free through AMT with a device called MT Connect. It allows you to put a thermocouple green light, patrol light directly to your phone so you can get simply a yes or no answer back. Is my machine running? Is it not? And this type of software is free. A lot of these adapters are capable of being downloaded at no charge, and the integration is fairly simple. So those are our 5 ticket items: redundant tooling, monitoring, parts collection, and additional storage. Well, I certainly appreciate your guys' time. Have a great day. Take care.